For this problem, we want to solve cosine of 4x is equal to negative root 3 over 2. I think a little bit of setup work would be good for this question, and that is, well, can we first think of angles for cosine, which I'll call theta, are equal to negative root 3 over 2. So essentially what I'm doing is I'm saying I'm going to let 4x equal theta, just so we have something simpler to think about. So, can I put something in place of cosine so I get negative root 3 over 2? So it helps me to look at a unit circle to figure this out. So here is my unit circle. Cosine is going to be the x-coordinates on this unit circle. So I know as a reference angle, and an angle theta is equal to pi over 6, or 30 degrees, I know cosine of pi over 6 is equal to, well, it's positive root 3 over 2. And I know cosine is negative in the second and third quadrants. So therefore, there's an angle here and an angle here where cosine is going to be negative root 3 over 2 instead of positive root 3 over 2. By using the symmetry of the circle, well, this is going to be 5 pi over 6. And the angle down here is going to be 7 pi over 6. These are two angles where cosine of theta is equal to negative root 3 over 2. But, not just these two angles. Every time that you add 2 pi to these angles, you also get that cosine is equal to negative root 3 over 2. So in general, you can say that, well, if theta is equal to 5 pi over 6, cosine is going to equal negative root 3 over 2. But anytime that you go around the circle, that means you go a total of 2 pi, then you get cosine still is equal to negative root 3 over 2. And the same is going to be true for 7 pi over 6. If you add or subtract multiples of 2 pi, you are ending up at the same location, meaning cosine takes on this value there. So this is the setup for the problem. Forget the 4x. Just think about places where cosine is equal to this value. And I used a reference angle to help me. And now I'm just stating, okay, well, theta has to be equal to this expression as well as this expression here. But the idea is to solve this equation for x, not for theta. So in place of this theta and this theta, I'm going to substitute and replace it with 4x. So this is really 4x is equal to 5 pi over 6 plus 2 pi n. And 4x is equal to 7 pi over 6 plus 2 pi n. It's nice to write it this way because now what you can do is solve these equations for x. I can do that by dividing both sides by 4. If I divide by 4, it'll go in this denominator and multiply to the 6, making it 24. And I also have to divide this term by 4. We'll have 2 over 4, and that'll cancel nicely for us. So what I'm doing is I'm dividing by 4, and it puts a 4 on the other side of the equations like this. So if I simplify, I get that x is equal to, well, that's 5 pi over 24, and then I have plus pi over 2n, and x is equal to 7 pi over 24 plus pi over 2n. To figure out all of the solutions in this interval will mean we'll start by putting n is equal to 0 into these expressions, and then increase n by 1. We'll check 1, 2, 3, and 4. And we want to make sure we get every single value that still falls within the interval from 0 to 2 pi. I included as a guide to find all of the solutions a graph of cosine of 4x, as well as the horizontal line y is equal to negative root 3 over 2. That way you can actually see all of the solutions that fall between 0 and 2 pi. And those locations are where the two graphs intersect. So I have 1, 2, 3, 4, 5, 6, 7, a total of 8 solutions. So like, what is this first solution here? Okay, this is going to come from this expression with n equals 0. So if n is equal to 0, we have x is equal to 5 pi over 24. And that is the location of this spot. If you want to get this location, we're going to put n equals 0 into this expression. It'll make this part equal 0, but x for n equals 0 is going to be 7 pi over 24, and that would be this solution here. Now, if you want to get this solution followed by this solution, what you're going to do is take n is equal to 1, put it into these two expressions to get the next two. So we'll do n equals 1. So we'll have x is equal to 5 pi over 24 plus, we'll add on pi over 2. We're going to multiply by 12 over 12 to get a common denominator of 24. But when we do that, we get that x is equal to, so that's going to be 17 pi over 24, which will be the location of this spot. In the one that's down here, we'll have 7 pi over 24 plus pi over 2, again multiplying by 12 over 12 to get our common denominator of 24. And this time, we're going to have 19 pi over 24, which is going to be this spot here. To get the last 4 solutions, we used n equals 0 and 1. So now we have to use n is equal to 2 and n is equal to 3 using the same procedure, plugging 2 and then 3 in place of n and solving for x. And that is the idea behind this problem.